So today we're going to be starting chapter 4, and in chapter 4 we're going to be discussing how to solve and apply proportions and ratios. So today what we're going to talk about is we are going to go over what a proportion and a ratio are, and then we're going to go into some specific details of ratios and proportions and how to solve those problems. All right, so number one is a ratio. A ratio is a comparison of two numbers by division. All right, you can um, you can write this in a couple different ways. You can do A over B, A colon B. You can also say um, A to B. All right. These are not examples. These are not examples that you would want of ratios. Okay. All right. So then we're going to go on to what a rate is. What a rate is. A rate is a ratio of numbers measured in different units. Measured in different units. So for example, we could say $1 is to 4/4. Now we know that these are equal, however, because we have the two different um, units, dollars and quarters, it's considered a rate. Same with this example down here. We have 1 dime to 2 nickels. All right. So, what we're going to talk about first is what a unit rate is. A unit rate is a rate with a denominator of 1. So an example would be 50 miles per hour. You could also write it as 50 miles per 1 hour. So that would have a denominator of 1. So for every 1 hour, we're traveling 50 miles. All right. So to find a unit rate, you divide the numerator and the denominator. So for example, Jeff drove 360 miles on 12 gallons of gas. Well, our goal is to get the denominator to be 1 gallon. So we want to figure out how many miles it would take for 1 gallon with this ratio. All right, so to do that, to get down to 1, we need to then divide these. So then we're going to do 360 divided by 12. And if you do that, you should get 30. So for every 30 miles, I'm using 1 gallon of gas. Or for 1 gallon of gas, I can travel 30 miles. All right, that's a great example of a unit rate. Your whole goal is to get the denominator to be 1. All right. We also have another example here. It says find the unit rate, cost per ounce for each amount of apple juice. Okay, which size has the lowest cost per ounce? So what we would do here is we would actually go through and we would create our ratios. So to save time, I'm just gonna go like this, make our unit rates a little easier to understand. Okay, these are colons. Okay, so we have 72 cents for 16 ounces. So then we would divide those two, figure out how much 1 ounce would cost. And in order to do that, we would then do 0.72 divided by 16, which we could find is 0.045 per ounce. All right, now we can do our second one where we have 1.20 divided by 32. And we're going to get 0.0375 per ounce. And our last one, we can do 1.6 divided by 64, and that's going to get us 0.025. So which has the lowest cost per ounce? That would be this bottom one. All right, so while you may think, oh, it's a little bit more money, you're actually getting more bang for your buck. This is a great thing to do when you're grocery shopping, when you need to figure out if you need to save some money. This is a great skill to learn how to do. All right. All right. So there's something else called a unit analysis. So within the unit ratio, we were having the unit rates, we were having the units work together. All right, now this one, we need to convert from one unit to another. So for example, we have a cheetah ran 30 feet in 2.9 seconds. What was the cheetah's miles per hour? So if you notice, we're talking about feet, and then all of a sudden we're talking about miles. Here, we're talking about seconds, and all of a sudden we're talking about hours. So we want to figure out how to go from one to the next. All right, so with that, we're actually going to need to set up our original ratio, which in this case would be 300 feet over 2.92, and I'm just going to use S for seconds. Okay, and our goal is to get to some number with miles per hour. Now, how on earth do we get there? We actually need to convert the feet and the seconds in different ways. Do this so it looks kind of like a 5. All right, so we're actually going to need to do some converting and some multiplying. So our goal is to get rid of the feet and get rid of the seconds. So what we can actually do is when we're going through, we can actually, just like you would normally reduce something if you had like 2/3 times 1/2, you could actually cross out those 2's because they're apart from each other. So if we had like 2/3 times 1/2, we could actually, instead of just multiplying across, we can make the problem easier by just getting rid of these 2's because they coincide. We can do that with our units here. So we always want to make sure that it is across like this. Okay, now and we want to get to miles. So for 1 mile, how many feet are there? Well, there's 5,280. All right. And then we want to get, so now we dealt with the feet to miles. Now we need to deal with the seconds to minutes. So since seconds are on the bottom, I'm going to put the seconds on top because I can actually get rid of those seconds then and put minutes right here. So I have 1 minute. For every 1 minute, there's 60 seconds. So what I can do now is I can say bye-bye feet, bye-bye seconds. And then if you notice, what's left on top unit-wise is miles. And what's left on bottom is minutes, which is exactly, which is almost what we want. So sorry, I'm jumping the gun here with my equal sign. We have to do one more calculation. we also need to get the minutes to hours. So for every 60 minutes, there is 1 hour. So I can get rid of my minutes. And then again, here we go. Now I'm left with miles over hours, which is what we want. So then I can go through and I'll multiply 300 times 60 times 60, which is which is 1,000,000 and 80,000. And then we can divide it by whatever 2.92 times 5,280 is. And you should get, if you did all the calculations correct, 70 miles per 1 hour. And that will be our answer. All right, the second part of our lesson today is to talk about what a proportion is. A proportion is an equation that states two ratios are equal. So for example, we have A over B equals C over D. All right, now with proportions, you can often find out if the ratios are proportional or equal by cross multiplying. Cross multiplying basically means that you are taking, for example, 2 over 3 equals 4 over 6, and multiplying across. So we're doing 2 times 6, which is 12, and 3 times 4, which is 12, which means these two are proportional. All right, so we can use this idea to actually solve proportions. So we're going to cross multiply. So we're going to have 10x equals 5 times 16. All right, and 16 times 5 is 80. So I'm going to have 10x equals 80. Divide both sides by 10, and our x should equal 8. All right. All right, same thing here. We could cross multiply, so then we would have 5x equals, and then 8 times 2, which is 16. And then x would be 16 over 5. And you can usually leave the answer in this particular form as an improper fraction. That's fine with me. All right. All right, we can also use this to use proportions to actually solve word problems. So for example, I have, if you can buy 2 heads of cabbage for $1.80, how many can you buy for $28.80? So we have a ratio in here. So for 2 heads of cabbage, it costs $1.80. And they want to know how many heads of cabbage does it cost, or can I get for $28.80? Now what I want you to notice is how I kept the units the same on both the top of my ratios and on bottom. So I kept my heads of cabbage on the top, and I left my money on the bottom. All right, this is very important. You want to make sure you're consistent. All right, so I have 1.8x equals 2 times 28.8. All right, and 28.8 times 2 is 57.6, which equals 1.8x. Divide 57.6 by 1.8, and I can buy 32 heads of cabbage. All right, so I'm going to leave you with one more example if you want some more practice with this. It says Haley was going to make punch for the party. The recipe she had made 12 servings, called for 3 cups of grape juice. Haley wanted to make enough for 36 servings, and so how much grape juice would you plan to add to the punch? So in this particular question, you would set up two ratios, one with an unknown in it, and then cross multiply to solve. All right.